Analytical. The way we build software has changed. Typing out lines of syntax is no longer the bottleneck. Natural language has become the primary interface used to instruct computers to autonomously construct programs. This shift created a frictionless honeymoon phase known as vibe coding. You write a single conversational prompt, and the AI generates a functional, working prototype almost instantly. But that illusion of effortlessness breaks as the application grows. As you add features, the AI experiences context collapse. The model's memory of your early instructions fades, and it begins hallucinating new logic or quietly overwriting code that was already working. Context collapse occurs when the volume of code and chat history exceeds the model's active memory limit. This chart shows the relationship between project scale and AI accuracy. During the early prototype phase, accuracy remains high. But as the project expands, the model loses track of the overarching architecture, and accuracy drops sharply toward zero. Relying purely on vibe coding trades long-term architectural stability for immediate, unearned gratification. You get an app today, but you cannot maintain it tomorrow. The root cause of this failure is that vibe coding skips the software development lifecycle, or SDLC. The SDLC is the standard engineering process of planning, designing, and testing software before deploying it. Without it, the AI is left to guess how your project's foundation should be structured. Spec-Driven development forces you to front-load the cognitive work by writing clear, strict requirements. You create an explicit execution contract that the AI must follow before it generates any code. This diagram contrasts an endless loop labeled vibe coding against a linear progression labeled spec-driven SDLC. Vibe coding traps you in a cycle of prompting, breaking, and reverting. Spec-driven execution moves you cleanly from planning to task generation to verifiable implementation. The core dilemma for modern developers is deciding exactly how much architectural rigor their specific project actually requires. An overly complex specification framework will stall a simple project in unnecessary enterprise bloat. Conversely, applying too little structure to a complex build guarantees irreversible spaghetti code. This chart maps AI coding workflows based on their setup time on the y-axis versus their long-term maintainability on the x-axis. In the bottom left quadrant is Tier 1, vibe coding. Tier 1 requires zero planning. You open a chat window, type out a vague desired outcome, and execute the prompt. The immediate benefit is speed. You receive functional boilerplate code fast enough to test an idea in minutes. The trade-off is brittleness. The AI makes irreversible decisions about your tech stack on the fly, which often break existing features once your prompt history fills up the model's working memory. Moving up the scale, we reach Tier 2, the DIY spec. This workflow is used by solo developers who need to strictly control the scope of their work. Tier 2 requires you to manually write a product requirements document, or PRD, and map out your database schema before opening an editor. A PRD is a plain text file defining exactly what the software does and what features are out of bounds. Forcing the AI to execute this document one task at a time prevents framework hallucinations and stops scope creep. The major vulnerability here is mental fatigue. The human developer must manually track which tasks are completed and continuously update the context state within the AI's chat window. Furthermore, Tier 2 depends entirely on the developer's ability to write a functional PRD.
The AI cannot follow a map if the map is flawed. The DIY spec grants solo developers the agility to build reliable applications, but it shifts the burden of execution tracking entirely onto human memory. To solve that manual tracking problem, Tier 3 uses lightweight tooling. Tools like OpenSpec automate the mechanical tracking required in Tier 2. Instead of managing text files by hand, Tier 3 relies on a command line interface, or CLI. You type short terminal commands to draft proposals and manage file changes. The tooling automatically updates your specification documents and isolates task execution. This keeps your large language model chat history clean and focused solely on the immediate task. However, Tier 3 has a ceiling. It lacks the ability to support diverse, multi-agent orchestration, which is necessary when building enterprise-scale features with dozens of moving parts. For that scale, we move to Tier 4, enterprise frameworks. Systems like Spec Kit are designed for large teams and legacy codebases. Tier 4 requires a constitution. This is a master file that establishes strict project guardrails,
like mandatory security standards and specific hosting platforms, before any code is generated. This diagram shows the core architecture of Tier 4, sub-agent orchestration. A central orchestrator node acts as a manager, breaking down the project and distributing specific tasks to specialized nodes, like a planner, a designer, and a coder. This isolation protects the architecture. Because the back-end coding agent operates in its own restricted environment, it cannot rewrite your UI styling while trying to fix a database query. The trade-off for this safety is friction. The cognitive overhead required to configure these frameworks shifts the developer's time away from the code and into a project management role. Heavyweight frameworks protect legacy enterprise code, but their strict rules can suffocate the momentum of a small minimum viable product. This flowchart provides a framework to map your specific project to the correct methodology. It all branches outward from one starting point, your project's expected lifespan. If you are building a weekend hack, your path is Tier 1 vibe coding. Hobbyists should avoid heavy processes. To maintain creative momentum, you have to accept that your code will be throwaway. Speed matters more than structure. If you are building a production MVP, you should adopt Tier 2 DIY or Tier 3 OpenSpec. Solo developers must reject enterprise bloat, but you still have to enforce upfront database schema planning if you want your product to survive its first real users. Successfully building software with AI requires matching your architectural rigidity directly to the anticipated lifespan of the application. Finally, if you are managing a legacy codebase, you must mandate a Tier 4 framework like Spec Kit. The Constitution file is an absolute necessity. It stops an eager AI model from attempting to rewrite your entire production tech stack just to execute a minor bug fix. Across all of these workflows, one reality remains constant. As AI models advance, a developer's daily routine shifts from writing syntax to defining strict requirements. Engineering now means defining system boundaries rather than manually crafting parts. You spend time reviewing plans and verifying logic that something else wrote. The choice between a single prompt or a multi-agent framework depends on how long you need the code to last. Building with AI doesn't remove the need for rigor. It just makes that rigor the only thing worth writing yourself.